This is a recording for section 11.6. We are still in the probability chapter, events involving not and or and odds. Suppose that the probability that it is going to rain today is 0.4. What is the probability that will not rain today? Well, we know 0.4 means 40%, so we know that it's 60% or 0.6. So basically, if we know there's two possible outcomes and we know the probability is not going to rain is 0.4, we know that the probability it will rain is 0.4, we know that the probability it will not rain is 0.6. They have to total 1 because remember 1 represents 100%. So down here, all right, the probability of event E is 1 minus the probability of not E. And the probability of not E is 1 minus the probability of E. Suppose that an urn contains 6 green balls, 4 red balls, and 8 yellow balls, all of equal size. What is the probability that randomly selected ball is not yellow? Well, let's figure out how many balls total. 6 plus 4 is 10, 18 balls. So one way you could add up all of the other colors of balls. This problem's easy enough to add up the other ones, but you can also say that, okay, there's a total of 18 balls, 8 are yellow, so I know 10 are not yellow, which is exactly what you get when you add 6 and 4, and it tells you to give your answer as a reduced fraction. Both of those are even, so of course I reduce, and I get an answer of 5/9. Suppose you draw a random card from a deck. What is the probability that's not a queen? So you probably don't want to go through the 52 and count up how many are not queens. Instead, that you're just going to subtract off from 52 the number of queens, and then that will be the number of cards that are not queens. So we know that in a deck there's 4 queens, one of each suit. So there's 48 that are not queens. So instead of adding all those up, we just take the total minus the number of queens. And of course, then we can divide this. You can start with 2 if you don't recognize 4 goes in. But I can see that 4 is going to go into both of those and give your answer as a reduced fraction. So in mathematics, or, the word or means to add. So or in probability means to add, but you need to make sure that you do not double count events. So you need to make sure that you subtract off if you double count, if they are not mutually exclusive. To be mutually exclusive, events A and B are mutually exclusive if it is impossible for them to occur simultaneously, which you will see in several examples. We'll first decide if they are mutually exclusive or not. So if they are mutually exclusive, they can't happen at the same time, then when you want probability of A or B, you just add them together, probability of A plus probability of B. If they are not mutually exclusive, then the probability of A or B, you add the two together, but you have to subtract off where you have double counted. Okay, like if you, for example, with cards, you know, if you want the probability of a king or a heart, well, there is one card that is exactly both, the king of hearts. So you don't want to count it as a king and count it as a heart, or you have a double counted, right? So the probability of a king or a heart is not mutually exclusive because you can get the king of hearts. So these first two looks like will be mutually exclusive. Suppose that an urn contains 6 green balls, 4 red balls, and 8 yellow balls, all of equal size. What is the probability that randomly selected ball is red or yellow? They can't be both, right? So you don't have to worry about double counting because a ball can't be red and yellow. So we just add them up. Or means, of course, to add. So we have 4 and 8, which is 12. And there's a total of 18 balls again. 12 of them are red or yellow. You could also write it as 4 over 18 plus red plus yellow is 8 out of 18 to get 12 out of 18 as well. Remember, when you're adding fractions, you only add the numerators and place them over the common denominator, or you could just here add the 4 and the 8 to start with to get 12 out of 18. Either way, I can see 6 is going to go into both of those. So that would be 2/3. Part B, what is the probability that randomly selected student is at least in the top 40? So that's the probability of the top 20 or the second 20%. In the top 40, it can be this one or this one. So you would just add them together. Or means add, and someone can't be in the top 20 and the second 20. So they are mutually exclusive events, right? Can't be in both. 0.41 plus 0.23, and it looks like that will give you 0.64. And again, the total of the probabilities in this chart should total approximately 1 whole, or 100%. The only time it wouldn't, it might add up to 0.99 or 1.01 is if there was rounding done. So or means to add events that are not mutually exclusive. What is the probability a randomly selected from a card from a deck is a king or a diamond? Give answer as reduced fraction. So you can look at the chart if you want. You know, or means to add, so you can do the probability of king plus the probability of diamond. But since they are not mutually exclusive, there is a king of diamonds, you would have to subtract off the probability of king and diamond. So the probability of a king, we know that's 4 out of the 52 cards. Diamonds are 13 out of the 52. Remember, there's 4 suits, 13 of each. But if you noticed, we've actually added the king of diamonds when we added the kings and when we added the diamonds. So we actually added it in twice. So we need to subtract off the probability of a king and a diamond, right? This is the king of diamonds because we counted it twice. So we have to subtract that off. So 4 plus 13 minus 1, so that is 17 minus 1. That should give you 16 out of 52, which of course reduces. 4 is going to go into both of those. So you should get 4 out of 13. The other thing you can do is look back at your chart, and I mean, you can think about it as well. You know, if you look at your chart and you have, say, diamonds, and you have 2, 3, ... and then you have king, ace, right? And then you have that same thing, ... king, ace, and you have that of hearts. Clubs, and spades. Ooh, that was really ugly. Of spades. So if you want the probability of king or a diamond, you would add up all of the diamonds. Could be either a king or a diamond. So it could be a diamond or it could be a king, right? So even when I circle those, you see I've circled that king of diamonds twice. So if you wanted to, you could do it this way. There's 13 diamonds, and then there's 3 extra kings, and get 16 out of 52, which is exactly we got that way, just by counting, right? So sometimes you can actually use both, either way. In a class of 45 students, 31 are Democrats, 4 are business majors, and 3 of the business majors are Democrat. If one student is selected at random, find the probability of choosing a Democrat or a business major. So there's a total of 45. So if we want or, of course, again, or means to add. So we'll do the probability of Democrat plus the probability of business major. But then, if you notice, there are some business majors that are Democrats. So we would have counted them in the Democrats and in the business majors. So we need to make sure that we subtract off those 3 people that we added twice. Probability of business and Democrat. The probability of Democrat is 31 out of the 45. Again, this is probability, meaning randomly selecting a Democrat, is 31 out of 55, plus probability of a business major, which are 4 out of the 45. 4 are business majors. But again, 3 business majors are Democrat, so I already counted them. I counted 3 here and 3 here, so I need to subtract off the 3 business and Democrat. So 31 plus 4 minus 3 should give you 32 out of 45, and 45 is 9 times 5, and 3 doesn't go into 32, so I know that that is reduced. Suppose that the sample space is the numbers 1 through 10. The set A is odd numbers, the set B is numbers greater than 5, and set C is even numbers. If a number is selected at random, find the probability of A or B. So we want the probability, the set A is odd numbers, so we want the probability of odd or greater than 5. Right, greater than 5 means that you are not including 5. So we can do or, of course, means to add. Let's show it both ways. We're going to use the formula in a sense. The probability of odd plus the probability of greater than 5. But then we have to subtract off the odd numbers greater than 5 because we counted them twice, odd and greater than 5. And then we'll see if we get the same result when we just count. All right, so there's 10 numbers. The probability that we select the odd one, 1, 3, 5, 7, and 9 are odd. That's 5 out of the 10. I would reduce your final answer. I would not be reducing here because then you'll have to find a common denominator. Probability of greater than 5, that's 1, 2, 3, 4, 5. Again, you don't include 5. Greater than 5 is 6 through 10, so that's 5 out of 10. Which, if we forgot to subtract off the intersection, we would realize it because 5 tenths and 5 tenths is 10 tenths. And we have several numbers missing, so we couldn't have a 100% chance probability. So we want to subtract off the ones that we double counted. We double counted odds that were greater than 5, and odds that are greater than 5 were 7 and 9. All right, so that probability is, those are 2 of the 10 numbers. Again, those are not mutually exclusive events because there are odd numbers greater than 5 in our sample space. Right? That's the time that we have to subtract this off, is when the events can happen at the same time. So 5 and 5 is 10, minus 2 is 8/10. Cut those in half, that's 4/5, or 0.8. Which you could also do this by counting. Odd or greater than 5, you would count out the odds. And then you would count out those greater than 5. And that would be everything except for 2 and 4. So you know you have 8 of the 10 numbers as well. So you don't have to use that rule in a sense. Probability of A or C, probability of odd, or again means add. C is even plus the probability of even. These are mutually exclusive because you can't have something, a number that's odd and even. If you want to write down probability of odd and even, that's fine, but you can't even have that, so that's just 0. Right? And if we want the probability of odd or even, all the numbers are either odd or even, so you know it's 100%. But odd is 5 out of 10. Even is also 5 out of the 10 numbers, which gives 10 out of 10 or 1, which makes perfect sense because everything's either odd or even. And it says which event is mutually exclusive, and of course that's this one, right? Because a number can't be both odd and even. Right? This first one, A or B, is not mutually exclusive because a number can be odd and greater than 5.